process of solving exponential and logarithmic equations involves transforming from one form to the other. We'll start with the exponential equations. Here are the three steps to transform the exponential equation into a logarithm equation. First, the base. In the exponential equation, the base is the 8. We'll write that at the bottom of the G. Number 2, the logarithm is the exponent. The exponent in the exponential equation is the x. And by process of elimination, the only thing remaining, 21, goes in this spot. So we have solved the equation. Next thing would be to get a decimal approximation, which we will just type on our calculator for that. And I think most of the homework problems are going to ask you to round to 3 decimal places. So to 3 decimal places, this would be a 1.464. So we're going to transform into logarithms. The base is the e. The logarithm is the exponent, which is the x. And by process of elimination, the 50 has to go in that spot. So this is log base E50, which we typically write as the ln of 50. If we need a decimal approximation for that, we'll take out our calculator and do the ln of 50. Again, to 3 decimal places, that comes out 3.912. Before we can transform to logarithms, we've got to combine these together. When we multiply two things with the same base, we add their exponents. So that would be 4x plus x minus 1, which comes out to be a 5x minus 1. We're going to use our transform steps. We'll write down log. The base is e. The logarithm is the exponent. And then the other thing is the 5e. Now this is the ln of 5e, which we can type into our calculator. However, to finish solving this, we need to add 1 to both sides. Over here, I'm going to simply on my calculator type a +1, and it takes the answer and adds 1 to it. I want to write it here as the ln of 5e plus 1. To finish solving, we need to divide that by 5. And again, on my calculator, I'm just going to push the divide key and 5. So there's our answer on the calculator. Here's how it looks in exact form. Now that is kind of ugly looking, but it is the exact answer. However, the approximate answer is 0.722. Now we want to switch to solving logarithm equations. The ln is log base e. The 4 on the front doesn't need to be there. So we're going to begin by dividing by 4, which would give the log base EX equals 9. And now we will transform that into exponentials. Here's the base, E. The logarithm is the exponent. And there's our answer. We would find the decimal value of that with our calculator. This one's probably not as bad as it originally looks. All the stuff that we see here, notice, is a single quantity. And here's the base. The logarithm is the exponent. And then the other number, which in this case is all of that. Now this is a quadratic like we did several times in the past. 3 to the third power is 27. When we multiply this out, here's the 4x squared plus 4x plus x plus 1. We can combine the x's. Subtract the 27. And then use our quadratic formula program on our calculator, which I've already done, and here's what it gives. So the calculator gives an x equals 2 and an x equals negative 13/4. Of course, with logarithm equations, we always need to check those two answers. Now we have modified the quadratic formula program so that as the solutions are computed, the first one is stored in y and the second one is stored in z. So to check our solution, we type the equation that's on the left side of the equals and see does it come out to be a 3. So using the log base, we're going to type inside the parentheses a second set of parentheses for the 4x plus 1, only we'll use the y. And for the x plus 1, we'll also use the y. And see, do we come out with a 3? Well, sure enough, this one works fine. So let's try the other one. We can make this a little quicker by going second enter, calling up the thing that we just typed, scrolling back over to the y, and changing that to a z. Now notice we also get a 3. So that means both numbers are indeed solutions. Now before we can transform this equation from logarithms to exponentials, we have to combine these two logarithms into a single logarithm. Using the properties of logarithms, when we have two logarithms added, that's the same as one logarithm where the two things are multiplied. you can review the properties of logarithms from an earlier section. Now we can convert from logarithm form to exponential form. Here's the base. The logarithm is the exponent, and then the other number is actually the other stuff. However, once we get to that point, it's the same as the previous problem. The 2 to the third power is an 8. When we multiply this out, we get 2x squared. Negative 5x and negative 6x is negative 11x. And then positive 15. When we subtract 8 from both sides, we get the quadratic equation 2x squared minus 11x plus 7, which we will now solve on our calculator using our quadratic formula program. Now these aren't exact answers. However, in the problems that we're doing in this chapter, we're always asked to round off our answers to 3 decimal places. Now, we need to verify that these are indeed both solutions by substituting those back into the original equation and see do they work. Like with the previous problem, we're going to type the left side of the equation, but using the y, which is where we have our answer stored, in place of the x. So again, very much like the previous one, we're going to do the log base 2 of the 2x minus 5, which we'll use a y in place of the x. Then we'll do the log base 2 of the x minus 3, which we'll use a y for, and see do we come out with a 3. Well, that's cool. That one checks out. We'll do the same thing, second enter, with a z in place of the y's. And notice this time we get complex numbers. We are not interested in complex numbers. So the only one that checks out is the first one.